everybody. We're here to investigate what happens with a slinky when there's two wave pulses at the same place at the same time. So let me send a pulse down. It's kind of a slow motion pulse. And then I'm going to pause this guy. And I'm going to send a different pulse that's got kind of a higher height and maybe a thinner width, just so that we can tell the difference between the two. So this new pulse, it's kind of taller. I'm going to pause this for a moment. We're going to try to keep in mind that one of these pulses is kind of taller and a little bit narrower, and then the second pulse that's going to reflect off this boundary is going to be shorter and wider at the base. Let's watch what happens when they come together at the same place at the same time. Did they bounce off each other? I don't think so. It's like they traveled right through one another. Okay, keep your eye on the pulse that's kind of tall. You see how it just kind of keeps on going through the other pulse? Watch. The pulses don't bounce off each other. They kind of mix and interact, and we actually use the word interfere in physics, but they pass through one another. Okay, the other thing we're going to look at is called constructive interference. And so for that, I'm going to send two pulses down my slinky, and we're going to watch what happens. We're going to make these two pulses identical to one another, and we're going to watch what happens to the slinky when they meet. Okay, so this guy's going to go down. It's going to reflect, and then after it reflects, it's going to mix with that other guy, and sure enough, it gets bigger when they come together. And they got bigger because they were on the same side. Okay, let's take a look at that again. It's going to bounce and maintain its amplitude, and it's going to interact with this guy here. And I'm just going to do this in super slow-mo as we go, because we would expect the height to be the algebraic sum of the two pulses, which would be about 1.5 centimeters. So on my ruler here, we see, yeah, look at that, 1.5. For destructive interference, we're going to get rid of our rulers, and we're going to look at what happens right there. And you'll see that part of that slinky, let me just bring up a quick arrow here, actually is not moving at all. Watch carefully. That the waves pulses mix and interfere. If the wave pulses are identical but on opposite sides, look at that. They've completely canceled out, and then they continue on through each other. That's what we call destructive interference. Okay.